Okay, so this is number 11 from 10A, and we want to find the order pairs of the integers. That's why this equation. So, first things first, we want to get a perfect square inside, right? So, and then we know that n squared minus 49 should be at least 0. So from there, so you can say n squared, if this is equal to 0, it has to be 49, and n could be 7 or -7. And if I plug 7, that will give you 0, right? Square root of 0 is 0, so m is like 0. So the pairs will be 0 and 7 or 0 and -7. So these are good. So which means we already have 2. Okay. But if this is not 0, we need something still perfect square. So when you look at the perfect squares, that will give us, but at the same time, I'm going to just write this here. So n squared minus 49 equals a perfect square. So let's call this is something like this. And if you add 49 to both sides, so you got n squared equals x squared plus 49, which is 7 squared. And I hope we remember this, like we are looking for the integer. So integer, like you have square of something equals sum of the squares of the other two integers, which is like a Pythagorean triples. And then when you have 7, so 7, 24, and 25 is one of the most like common triples. So which means x could be 24 and could be 25. So if I choose that, so let's try that. If I plug this 25, right, that will be 25 squared minus 49. So the entire thing will be 625 minus 49, which is 576, which is 24 squared. So the m will be 24. So which is our result. So that means I will say 24 comma 25 is another one. But n could be negative as well, because even though negative number doesn't work with a triple, but in this equation I can square negative of that 25, so you still get 24 as your result. So these guys, the m's has to be non-negative, okay? Could be 0 or positive. So we have 4 so far. So these are not gonna correct. So the question you should probably ask, how do I know there's no such a thing, right? So maybe just 4, maybe more than 4, but how do we know there's nothing more? Like we can just test that, like a couple other stuff, but if you plug like something larger than 25, right? So you get a positive number, which is good, but you should be getting perfect square from here as well. Let me just try this as like, if you square both sides, now we're saying, so n squared minus 49 equals m squared. And then if you add 49 to both sides, maybe I should use x, but I just did it, so it's fine. So the n squared equals 7 squared plus m squared. So with 7, 24, 25, that's the only triple that is primitive roots of the Pythagorean triples for that set. So which is why only 7, 24, 25 does work. So for this equation, when you have some one of those numbers, so that's why there's no other like m and n we can have. Some people may feel like, okay, how about the changing the sign of the 24, because that satisfies the equation, but we cannot have negative value when you have the square root of a number. So this result has to be positive. So which is why we do have only 4 solution. So that was number 11.